Hello guys, welcome back for another virtual instruction on quarter 1 week 7 with learning competency factors polynomials. We will discuss factor theorem. This is Mr. Frederick M. Alvarez from Cabarwan National High School. Factor theorem. A polynomial function has a factor x minus c if and only if the function of c is equal to 0. So let's have an example. Determine whether x minus 2 is a factor of f of x is equal to x cubed minus 6x squared plus 3x plus 10. The value of c is obtained when the linear factor is expressed in the form x minus c. Since the divisor is x minus 2, therefore c is equal to 2. Using our polynomial function, we substitute 2 to our variable x. So we have f of 2 is equal to 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10. So we have 8 minus 24 plus 6 plus 10, or the value of the function is equal to 0. It means that our remainder is equal to 0. Since there is no remainder, it can be said that x minus 2 is a factor of f of x is equal to x cubed minus 6x squared plus 3x plus 10. Let's have example number 2. Show that x plus 3 is a factor of f of x is equal to 3x raised to the 4th plus 9x cubed minus 4x squared minus 9x plus 9. Since the divisor is x plus 3, this is the same as x minus quantity negative 3. Therefore, c is equal to negative 3. Let us use two methods this time to show that x plus 3 is a factor of this polynomial function. First, let's have the remainder theorem. We use negative 3 as the value of c and substitute it to our variable x. So we have 3 times negative 3 raised to the 4th plus 9 times negative 3 raised to the 3rd minus 4 times negative 3 squared minus 9 times negative 3 plus 9. Then we have 3 times 81 plus 9 times negative 27 minus 4 times 9 minus 9 times negative 3 plus 9. So we have 243 minus 243 minus 36 plus 27 plus 9 is equal to 0. Therefore, the value of the function is equal to 0. Then, if we use the synthetic division and we use negative 3 as our divisor, so it shows that our remainder is also equal to 0. Since the remainder is 0, it can be said that x plus 3 is a factor of f of x is equal to 3x raised to the 4th plus 9x cubed minus 4x squared minus 9x plus 9. Let's have example number 3. Find the missing factor of the following polynomials given the binomial factor. In order to find the missing factor, we have to divide the polynomial by the binomial factor, and the quotient will be our missing factor. Since we are looking for or we are using division, I advise to use the synthetic division. So for letter A, since the divisor is x plus 1, we have x minus negative 1, therefore c is equal to negative 1. So we are going to use negative 1 as our divisor. So by using synthetic division, you bring down 1. 1 times negative 1 is negative 1. And then 6 plus negative 1 is 5. 5 times negative 1 is negative 5. 11 plus negative 5 is 6. So 6 times negative 1 is negative 6. Then our remainder is equal to 0. So 1, 5, and 6 are the numerical coefficients of our quotient. So our quotient is x squared plus 5x plus 6. Therefore, this will be our missing factor. So x cubed plus 6x squared plus 11x plus 6 is equal to x plus 1, since the value of the function is equal to the divisor times the quotient. Therefore, our missing factor is x squared plus 5x plus 6. So let's have problem B, where the divisor is 2x plus 1, wherein the numerical coefficient of x is greater than 1. So we can rewrite our divisor in the form x minus c. So we have x minus negative 1/2. Therefore, c is equal to negative 1/2. So by synthetic division, we use negative 1/2 as our divisor. So we have to bring down 4. So what is 4 times negative 1/2? And that is equal to negative 2. So if we add negative 16 plus negative 2, that is negative 18. So negative 18 times negative 1/2, that is positive 9. So 11 plus 9 is 20. So 20 times negative 1/2 is negative 10. So our remainder is equal to 0. Our quotient will be 4x squared minus 18x plus 20, and our missing factor will be 4x squared minus 18x plus 20. Let's have example number 4, our last example. Find the factors and the roots or zeros of f of x is equal to x cubed minus 3x squared minus 10x plus 24 if x minus 2 is one of the factors. So in this example, we are going to find the factors and the roots or zeros of this polynomial function. Since we are going to use x minus 2 as the divisor, therefore c is equal to 2. And we are going to use synthetic division in order to find the factors. So we have 2 as our divisor, so bring down 1. 1 times 2 is equal to 2, so negative 3 plus 2 is negative 1. Negative 1 times 2 is negative 2. We add negative 10 and negative 2, so we have negative 12. So negative 12 times 2 is negative 24. So 24 plus negative 24 is equal to 0. So our quotient is x squared minus x minus 12, where it is factorable. So the factors are x minus 4 and x plus 3. Since one of the factors is already given, which is x minus 2, therefore the factors of this polynomial function are x minus 2, x minus 4, and x plus 3. Now, to find the roots or zeros of the polynomial function, we are going to equate each factor with 0. So we have x minus 4 is equal to 0 and x is equal to 4. So x plus 3 is equal to 0, where x is equal to negative 3. So the roots or zeros of the polynomial function x cubed minus 3x squared plus 10x plus 24 are 2, where it came from x minus 2, and we have 4 and negative 3. Thank you, and stay tuned for the next virtual instruction.